Hello, everyone. My name is Neetu Rajpal. I am the VP of Product Development at Conductor. We use Slack extensively, including a whole bunch of stuff that I'm going to talk about today, and it's actually, in fact, helped our CI process got a lot smoother as well. So remind me to tell you everything that we do with Slack with CI process if I forget to tell you. So I started at Conductor about 2 years ago. 2 years ago, I started at Conductor as the Director of Quality. And at that time, the world was somewhat bleak, and I'll get to that in a minute. But before that, I was at Microsoft for 18 years, and my last gig at Microsoft was working at the Office 365 service on the anti-spam and antivirus products that were online. So I want to talk a lot about continuous integration today. But before I talk about continuous integration, I kind of want to give you a view into what Conductor does and what the product is. So this is a screenshot of one of the pages on the Conductor Searchlight product. So Conductor, we have a single product called Searchlight. As Dan mentioned earlier, Conductor helps companies figure out what their customers are looking for on the web, and then help them figure out what content they should be creating and soon in what channel, and how to track progress against are people finding their content? Is that actually helping them improve their business? So this is one of the slides, one of the pages on the site that helps you figure out if I'm creating content, a huge number of my competitors are creating content as well, and how am I tracking against the content that I care about versus the competitors that I have. On this page, I want to point out a couple of things, and I'll tell you why in a second. So the page is built using multiple versions of JavaScript. So Conductor's been around for 6 years, and there have been several business twists, and there have been several technology twists. So we've ended up with an application that's extreme giant monolith, and I refuse to apologize for any of it because it's the thing that's helped us be successful, and we're in fact a very successful company. So I refuse to apologize for any of it. It is just the state of the world that I live in. Or at least I lived in 2 years ago. There's data that comes here from S3. There's data that comes here from a terabyte big SQL server. There's data that comes here from multiple other smaller databases. They're not just MySQL. There's also there's Redis cache that I'm talking to at points. There's Elasticsearch that I'm talking to at points. There's definitely S3 I'm talking to at points. It's hosted on a Terracotta machine, and it's a load balanced, Terracotta instance on AWS. So that's the background for where it is. So you can imagine I have a large code base that is just you can probably look through and find most languages represented somewhere on this page. Actually, not this page anymore. This is the nice page that we just released a couple weeks ago. So this is much smaller, but they're the wrapper pages anyway. So that was our starting point about 2 years ago. Monolithic application, serious inability to be able to commit to a date for features, which obviously means your customers don't love you as much as they should. There were customers that were actually leaving us, and they were telling, look, I like what you're doing, but I can't trust the quality anymore. And that's not a good place to be if you're trying to be a startup that's trying to take off. Whenever we wanted to release code to production, sometimes it took a day and sometimes it took a week. And that's kind of a stupid way to run an engineering org, I think. And once we actually got code into production, it was pretty unclear as to how many bugs are going to hit us back. And that's not a very comfortable place to be. So all of these are pretty uncomfortable places to be. At the same time, we had a bug backlog that was growing. We couldn't ship features really fast, all of this stuff. So, if you've been writing code for more than 5 minutes, you've probably heard of continuous integration. And I think this should just be a truism, you know. You should be able to push your code into production. You should be able to rely on your code actually being in production and not breaking everything else along with it. So we started with this. We said, you know, we're going to accept this as a truism, and we're going to see how close we can get to it. And of course, there's like, once you get to the other side, there's unicorns and rainbows, and you just have to have magic in the middle, right? Like everything's going to be great, integration's going to be great, and you're going to be able to push code out every 3 hours, and you know, the world's going to be awesome, and you're going to catch issues before anybody sees them. So that all looks very much like magic if you live in a world that has giant monolithic application with lots of different technologies, one build process, circular dependencies in your code base. So you start with, okay, magic and unicorns and rainbows, and then you hopefully get to the point where you say, all right, take a deep breath. I'm going to do a connects the dot exercise. And that's kind of exactly what we did, which is, I know the world I want to get to. I know I can't get to it today. What are all the things that I need to do? Can I document them? Can I actually list them out? Which are the 5 things that I need to do now? We had a team. I have a fabulous team. My team is full of brave hearts, essentially, that are willing to go do this with me, that are willing to say, I don't know what the world looks like, but you know what? Let's jump, because I don't like the way that I live right now. So I'm going to go build whatever I need to build. The key was to actually pick each one of these dots to be a measurable thing, to be a bite-sized chunk, to actually deliver value at any point, so that if it so happens that you're now busy shipping a feature, you can half draw the picture, walk away, come back, and you didn't lose all of it. You can just continue to the next dot from there. So that was a very important thing for us to do. So here's where we started. Dot number 1. The world is crashing, we can't have releases, blah, 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 blah. So, okay, first of all, put a giant duct tape on the whole thing. Put a giant duct tape, stop all the bleeding, make sure we're not hurting as much as we are now. So we standardized the release process completely. We identified all the tests that we had to run that are end-to-end tests only. So they are the worst kind of tests you can really write, because they take too long and they are manual sometimes, and they're really the worst kind of tests you can write. So, but we needed a duct tape. That's the first thing we did. We put a duct tape on the whole thing. We also did something that was very important and helped us quite a bit, which is we didn't trust our full set of test suites. So we didn't know if we ran all the tests and released code to production, if it was good or not. So we wrote production level monitors. That was the first automation thing that we did when we started down this journey, as in, I'm going to check production to make sure the scenarios that I care about are actually still functioning properly. And if they weren't, we pulled the code back immediately and tried to figure it out, and then pushed it back out again. So next thing, we tried to very carefully balance the rest of the pieces. We had put a duct tape, but now it was kind of backlog, right? So everybody's writing a lot of code and they want to get it out, and how do you get it out? So we went on a stability binge. We stabilized any existing automated test cases that we had. We identified large feature areas. We essentially went around and surveyed what features are actually used more and which ones are not. So we surveyed those feature areas. We talked to our product managers and customer support people, and we identified all of the different scenarios that actually people care about, and we went about writing automated tests for them. And so we automated everything that mattered. We automated it in a inefficient manner, and I'll get to that in a second, but we automated it. Now when we knew that when we push code out to production, it's very unlikely that we'll have to pull it back, because we knew all the major scenarios worked. At the same time, you can't do continuous integration or delivery in any team if all you do is write tests. That's not gonna help. That is Band-Aids. We just talked about it. It's Band-Aids. We also put in a policy in place where you aren't really allowed to check in any code if you also don't have either a unit test or an integration test or end-to-end cucumber test to cover the scenario that you just wrote. And in fact, not just the scenario you wrote, but also any of the edge cases. So we have a bad situation, we're trying to improve it, don't make it worse. You know, let's try to at least hold the line, so don't make it worse. We also implemented policies around writing better code, so we implemented mandatory code reviews. It was an interesting start because people hadn't done code reviews before, and how do you do a good code review? What's a good code review? I identified the variable names were wrong. Who cares, right? Like, so we had to learn what a good code review is, and we were able to get to a point where we documented what good code reviews look like, and we were able to apply it. And now we have some people who've emerged as great code reviewers because they've put in the effort, and it's essentially like they built the gut for what code looks like, and they can look at it and tell you if it smells. And if it smells, it's not going out. Another thing that helped with this code review item was there were some teams that had better code review culture than other teams, so we would cross code review. And sometimes that helped, and sometimes it wasn't helpful because subject matter expertise mattered. And then once we had put the Band-Aid on, we had stabilized a little bit, then we were able to predictably send out releases. They were still very slow. You could send them out every week, but once a week only. It took 2 days to run the test pass and verify failures. For those 2 days, none of the QA engineers did anything other than verify test cases failures, and we still found a ton of bugs at release testing, which essentially meant that we weren't testing early enough, right? So we were way up the line over there. It just meant we were paying for all of this in like intense human capital and pain and terrible on-calls and unhappy people. And once you found bugs over there, you also filed bugs, which means, you know, the developers were actually trying to fix bugs before code went out, which essentially means they weren't writing features that they committed to date for. They didn't know where the code broke because it's a week-long amount of code. So now they have to sift through a lot more code, and it's very difficult to figure out, debug that piece. So since then, the most amount of time that we've spent, so the first quarter or so is within like the first quarter and a half, we were able to get to number 2, maybe 2 quarters. Since then, we've spent about 3 or 3.5 quarters just doing this, right? Like if you were looking at this for the dots, it would look like a Pleiades cluster, as in you just stare at it and you see more things. But we painfully repeated ourselves. We wrote down everything that we needed to do, and we followed through. And that actually helped us get from being able to release once every week to just being able to send out releases every day. We are now at a point where we choose to not send out release if we don't want to, but we can if, you know. But none of that happened without, you know, this feels obligatory whenever you talk about CI/CD, but it is in fact true, at least it's proven true for us. The first thing we had to do was like get this going in some shape or format where we had this structure going. So we were able to write code, we were able to test code, we were able to, so test, build, code, plan, release, deploy, operate. All of these things, we did all of these things, and probably a few more, some of them better than others, and initially a lot of these things were like manual. I think test had too many manual pieces. I think build was I think we're still working on parts of build, but everything here we had to do. So we picked TeamCity as a tool. This is a picture of a job that we ran in TeamCity earlier this week. Yesterday, day before, yesterday. So this is one of the code check-ins that we did yesterday, and as you can see, now this looks like a respectable software company set of things you might want to do, as in you might want to actually launch some environment to run a test. You might actually want to run a set of end-to-end tests that is small and manageable. You might want to actually run some smoke tests before you do things. You might want to actually run code coverage. You might want to actually do all of these things. When this first started, it was like 3 lines. You know, it was basically included build It barely had unit tests that were reliably running. There were a couple of other, and our latest things these are our latest things. So ESLint, I promised to not look too far, and I did. ESLint is our latest thing, but before we could get to ESLint, we had to get rid of old JavaScript code. So there were portions of the CI experience that needed to land in DevOps. There were portions that landed in QA. There's definitely portions that landed on the dev side. So this isn't a single team activity. So that's what our world looks like now. And we have a suite of like 5 more things we want to do probably. So going back to what good code would look like. I know I blotted out everything that might be personally identifiable. I've spent too much of my life working on security software, so just couldn't get past it. So, but if you want to meet these people, I will help you. But this thing, so Team City, you turn it. As soon as you start a pull request in Git, TeamCity has a plugin that picks it up. It picks it up. You don't have to start it. You don't have to go to GitHub to start a pull request at all. We actually wrote a tool. We wrote a tool that essentially submits your job, asks you a bunch of questions. Did you do a code review? Who are the people who did the code review? Where is the fisheye link to your code review? Did you commit? You squash all your commits? And there's like 5 other things it asks, but. So there are some portions that are manually enforced, as in, did you do a code review? But then there are other portions that are not. TeamCity picks up creates a pull request for you, answers all these questions, and then kicks off that giant job that I showed for you. And at the end of it, it's either a green merge button or it's a red merge button. So, and then still a person has to go merge it. So it's still not like true CI because we don't let you merge into master automatically. We still live in a monolithic application. So, and also our PR system is doesn't always work 100%. It works about 80% right now. So the other thing that this took really long time, and it looks like a toy, but trust me, it's not a toy. We have a monolithic application that lives in a very large infrastructure, right? So yes, I know this is anathema for anybody working on microservices, but that's the world I live in. We didn't have reliable test environments. If we want to move up the chain and find bugs sooner rather than later, you have to be able to test your code sooner rather than later. Unit tests and integration tests will tell you so much, but it won't tell you about functional tests. So this was an important thing for us to be able to create test environment that was a representative of the production environment. It sliced the data, it worked faster, some features just weren't represented. But you could, in fact, run a very large swath of functional tests. So this is a huge portion of our infrastructure. It took us at least 3.5 sprints to build this, and this was pretty important because we didn't have the option to do a blue-green deployment, at least not then. And if we get to the point where we have blue-green deployment, this would be less useful. This we built in a Dockerized environment. So all of the pieces are Dockerized. There's a giant Docker registry that supports it, and we discovered scale issues as we went along, because if you make it possible for people to run functional tests, then more people run functional tests, which means you need more scale. So we ran into that problem, and that problem was a good problem. So talking about problems we ran into, right? So our Team City agents would run out of space. So we had to get bigger ones. Our test environments would die, right? As in, because we deployed those representative test environments on Docker boxes using Spot instances on Amazon, so they would just take away Spot instances, and we weren't very smart in how we got Spot instances. Our Docker registries couldn't handle the scale of the number of boxes we wanted. We needed too many Docker boxes at some point. Our test infrastructure, our Selenium grid couldn't handle now the amount of load, right? When we only had 10 PRs happening at the same time, it could run all the tests. But if you have 30 or 40 happening, it couldn't. So all of the engineers and all of the QA people in our team are in fact software engineers, and they decided, you know what, I'm just going to take that grid and turn it into a Dockerized grid as well. So now every PR gets its own Selenium grid. That's how we solved that problem, and we got smarter about how we bid, and we're able to do a lot more of these, and some of them felt like there's just something wrong I'm doing, this is probably a really bad idea, I need to go home and go to sleep. But yeah, some of them really threatened to undo everything that we did. There was a point where we had to stop all PRs. There was a point where we missed one of our feature dates by 4 days, which, you know, if you've gotten used to shipping on time, 4 days feels like a lifetime. But, I mean, back to my team. My team is awesome. They stuck with it, right? They're like, all right, we can't send out anything, but we have some capacity for pain still, so let's not ignore everything that we've done. Let's not just submit every PR into master again. And it only took a little bit to get smarter about how we did things. So I don't think we're 100% there, but this is the slide I started with. We lived in a world where all of these things are true. I still live in a world where I have a monolithic application, but I now live in a world where I ship code on time. This year we're already onto our second release that we're targeting. There's a very large number of bugs. We've already caught up to the product team, and they're like now like running around with their heads cut off, as in like, what do you mean you need more features to write? So that's the world we live in now, and I'm happy to be here, but I don't think I'm 100% there. As soon as we go to Q&A, I'm sure you're going to ask me about, hey, you said continuous delivery. What's up with that? We don't do continuous delivery. We don't do continuous delivery because we are still not 100% sure that our application can actually hold up. However, 90% of the times, it's essentially automatic ticket creation for deployment, which posts as a Slack bot, which is a Slack bot that posts. Automatic list of commits that are in that particular release, which is also a Slack bot, which then gets picked up by somebody who is on the customer support side, turns it into a README that is used for various things. And then the release, somebody essentially goes to Jenkins and presses a button for deployment. Most of the times that goes normal, and we get updates in the Slack, in Slack with Slack bots. Most of the times it's just that, but there's always 1 or 2 times when that is not the case, and until we get more comfortable doing that, I'm not going to call that Jenkins job from Team City, which is all we need to do to go to continuous delivery. That's my slides. Questions?
Yeah, so on one of the slides of one of those green things you didn't erase, there was like 6,000 or 8,000.
No, I intentionally.
Somewhere here, yeah, like at the bottom. So how big is this team? What's the size of the project?
My total team is about 45 people. There's about 8 feature teams. Each feature team has 1 QA person. It's intentionally designed to not have enough QA people, so you cannot offload test writing. We've tried very hard to push the requirements for quality all the way up front. So when you now write stories, your acceptance criteria essentially turn into automated tests. And if they're not automated tests, it's a bad thing. Over a period of time, one of the blocks that we hit was one of the requirements that we set for ourselves was each PR needs to take no longer than an hour and a half, 2 hours. And there was a time when the number of cucumber tests that we had just took a really long time, and that we ran for each PR. So then we got smarter, and we actually had, we reviewed what tests we needed to remove, and we removed some tests and added like additional integration and unit tests. And when we did the measurements, our fastest cucumber test was running 4 times slower than our slowest unit test. So that's with all of the multiple node, very large grid machine, all that, including all of that. Even then, Cucumber was running really slow. So we've been writing a lot of unit and integration tests. And the thing that you see here this gives us, we're experimenting with code coverage for JavaScript. If we can get enough of that, we can get rid of even more. Smoke tests are always going to be there. They're the basic integration tests. The end-to-end tests, we can get rid of any additional iterations of things that we don't need to. So
at what point do you break up the monolith, the 45 developers writing into a single monolith?
we have projects ongoing now to start moving into microservices. We have folks on the DevOps side that are breaking up the code base. So we've already started. This can't last, right? This can't last. Yes.
I have a bit of rhetorical question, and this is a great set of practices, no question about it. But my point is that they're all about 25 to 40 years old, and I know that because 20 years ago, I've been with exactly the same thing, with the same set of problems, with exactly the same results, pretty much implemented exactly the same set of practices, and it was great at the end. Well, the question is, are we doomed every cycle of new software companies to do exactly the same kind of mistakes and try to resolve them with exactly the same set of practices on a different level? Because your tools are obviously much better than what I had 20 years ago here. However, we did exactly the same thing, exactly the same set of policies for actions, and the process was pretty much one-to-one.
My short circuit answer is yes. You know, I'm just as old, probably. You know, I started my career working on Internet Explorer 3, so I agree with you. But I think there is one very large difference, and I think the difference is this, which is for like, if I look at my whole career, more than 50% of it I've spent shipping on-premises software. On-premises software by default presents a different set of challenges and opportunities. The challenges essentially include, I need to ship code that I cannot recall. Right? I cannot recall, I cannot force anybody to do a service update, I cannot make sure that I fix a bug. So essentially, the requirements are very, very strict. When I work on a SaaS product, I own the delivery mechanism, I own the deployment, I own the cycle for how fast things can go out. I also own the ability to pull it back in case I made a mistake. And that, I think, is a critical difference between how you build software and ship software for on-premises versus how you do it for services. Is the theory the same? Yeah, it is exactly the same. Don't write bugs. I mean, there's.
I totally agree with you. I'm in exactly the same boat. And in my case, we were building air traffic control systems, so when it goes down, it takes slightly more than the website goes down. You know, lots of people are getting pretty happy when, you know, planes can run. However, producing the quality software actually requires pretty much the same process. I mean, the kind of problems you're dealing with is very relatable.
I agree. I think there are relatable problems. I think there are some nuances that require, you know, some fine-tuning, and there's lots of opportunity to take advantage of the fact that I control the deployment infrastructure. I control the hosting. There's huge advantage to all of that, to have such tight control over it.
But your cost curve is going to be exactly the same, and you want to push the discovery of the bugs as early in the process as possible.
Much longer discussion, yes.
Oh, yeah.
Yes, very long discussion.
Let's one more question. Thought there's one over here. Oh, go ahead, Toby.
What's the code review process that you assemble the plan?
So code review. So over a period of time, we've actually come up with some people who have really good code sense and some people who don't, and we've created a class system. So it is true. We've created a class system. You must get a code review from at least the team lead or the engineering manager that's in that team, and one other person. That forces the team lead to know everything that he or she is now responsible for. Two, the engineering manager, because they, I would have very much liked if the engineering manager was on every code review, because then I get the wealth of experience that they can bring to it. But we can't, because that's just like not really possible because of time. So every once in a while they'll jump in and do that. And then another person in the team who is probably not a designated senior or whoever, because then it forces them to learn what is good and what is bad. There's no official guideline for you will write code better this way. Over a period of time, some teams stick very, very close to effective Java. As we move to Scala or as we move to another language, I think we're going to have to redo the actual guidelines. But the other thing we're trying to do with ESLint is some of the things people do should just be, they should just be caught before you even get to a code review.
All right, Neetu, thank you very much.